welcome back. We are discussing the lesson, is matter around us pure? By now we already know that matter exists both as pure substances as well as mixtures. Today we are discussing the topic mixtures in detail. So what is a mixture? So when two or more pure substances are mixed physically, then we call it as a mixture. So to understand the types of mixtures, let us do a small activity. For this, we will take a test tube and we will take water. Let us add ferrous sulfate crystals, quarter of a spoon of ferrous sulfate, put it in water, and in the second test tube, let us take calcium oxide powder, CaO. We are mixing two pure substances. Water is a pure substance, ferrous sulfate is a pure substance, and calcium oxide, which is a compound, is also a pure substance. So let us take quarter of a spoon of calcium oxide. So you get a milky white mixture. You see that in this particles are completely dissolved. They are uniformly dissolved. Whereas here you can still see that the particles are in a suspended phase. What are these type of mixtures called as? Based on the activity, we can classify mixtures into the one here on the left hand side, where particles are completely dissolved and uniformly dissolved, and one on the right side where particles are not uniformly dissolved. So we can classify mixtures into homogeneous and heterogeneous mixtures. Heterogeneous. Homogeneous mixtures are called as solutions. Whereas heterogeneous mixtures can be further divided into two more types. This here, where particles remain suspended, are examples for a suspension. And there is a third type that is called as a colloid. What is present in a solution, or what are the components of a solution? For example, this case we had ferrous sulfate and we had water. So these are the two components of water. In this example, which component was present in maximum amount? Water, right? And which was the component present in minimum amount? Only quarter spoon, that was ferrous sulfate, right? So in a solution, the component which is present in least amount is called as a solute, and the component which is present in maximum amount or volume is called as a solvent. Usually, solute is dissolved in the solvent. Solvent is the one that dissolves the solute. Such type of solutions as solid in liquid solution. Solid in liquid. Example, salt solution. When you dissolve salt in water, or sugar solution, where water is the solvent, salt or sugar is the solute. Another example for solid in liquid solution is tincture iodine. This is most commonly used in clinics and hospitals in cleaning the wounds, that reddish brownish colored liquid solution that we use to clean the wound. What is that? That is nothing but iodine present in alcohol. Here iodine is the solute and the solvent is alcohol. Alcohol is the solvent. Liquid in liquid solutions, where both solute and solvent are in the liquid phase. For example, alcohol and water. Nowadays, because of this corona, we are using the hand sanitizer spray. If you look at the ingredients, what is it? It is nothing but 70% alcohol would be written in that. What is this? Here it is 70 ml of alcohol present in, added in 30 ml water. So both are liquids, alcohol and water. 70% alcohol, very effective in killing bacteria and virus. Then example for gas in liquid solution, soda water or soft drinks. So in this case the solute is carbon dioxide gas and solvent is water. When you open Pepsi or Coca-Cola, you get that fizz sound, or you can see bubbles coming out. So it's a type of homogeneous mixture. Based on the amount of solute and solvent, we can discuss a parameter called as concentration of solution. What is the concentration of a solution? Means how much of amount of solute and solvent is present. Based on this, let's take an example. There are two beakers, both contain 100 ml water. To this we add 20 gram of salt, and to this I add 50 gram of salt. In this case, the amount of solute is lesser when compared to the amount of solute here. So we can call this solution as a concentrated solution, whereas this solution will now be called as a dilute solution. When compared to this is a dilute solution. When compared to this is a concentrated solution. So the concentration of a solution can be given by the formula. In this case, the mass of solute is 50 gram. The mass of the solution, this solution has 100 ml water. It also has 50 ml of the salt that we dissolved. Therefore, the total mass will be 150. So, if you do it into 100, you get the percentage of a solution. So, percentage would be 33.3%. In this case, it would be 20 by 120, 100 ml of water, and total mass of the solution would be 100 plus 20, 120. So that is, you would get the answer 16.6%. When compared to this is a dilute solution. Now, there is one more term, which is what is called as a saturated solution. we take 100 ml of water and to that we add 10 gram of salt and completely dissolve it. Once everything is dissolved, let us say add another 2 gram of salt, dissolve it, another 2 gram, dissolve it. At one point of time, no more of the solute will be dissolved in the solvent. That is, the solvent has taken the maximum capacity of solute it can dissolve. Now, this solution is called as a saturated solution. So, at a given temperature, at that given temperature, the particular amount of solvent has taken the maximum possible solute. Then we call it as a saturated solution. This parameter is very important at a given temperature, because if we heat the solution now, after heating, if you add some more solute, it will get dissolved, because on heating particles are free to move. When they move here and there, some more space is created. So when you add solute, it can further get dissolved. Take for example this. So what is the property of this? Now one thing is, if you see, the particles are uniformly dissolved. A solution has a uniform composition. Throughout the solvent, solutes are uniformly distributed. Particle size. Can we see the particles with our naked eye? No, we cannot. So particles are minute. Their size is less than 1 nanometer. Very small. Because the particle size is less than 1 nanometer, it is completely dissolved. It is a stable solution. If you leave it aside for few hours also, you will not find anything at the bottom, because it is a stable solution. And another property is that when we pass a beam of light through this solution, there is no scattering of light, because when the light is traveling, the particles here are very small, so there is no scattering of light. Because the particles are small, we cannot separate the solute and the solvent by filtration. If I pass this solution through a filter paper, will I get water and ferrous sulfate separately? No, right? So you cannot separate the solute and solvent by filtration. Let us now go to heterogeneous mixtures, that is suspension and colloid. Right. This one here is an example for a suspension, because particles remain suspended in the solvent. They are always suspended. Why? Why are the particles suspended? Why are they not dissolved completely? Because as you can see, particle size is bigger. You can see the particles with your naked eye, unlike a solution. So let us note down the properties of a suspension. And another property, is it uniform in composition? Are the particles uniformly distributed everywhere? No. Here particles are less, at the bottom particles are more. So you can see layers. 2 layers can be seen distinctly. Therefore, they don't have uniform composition, non-uniform composition. Particle size is larger, it is visible to our eyes. So it is greater than 1000 nanometer. So we can see the particles with our naked eye. Now because of that, because the particles are bigger, you can see after some time particles start settling down at the bottom of the test tube. So particles are unstable, they are not completely dissolved in the solvent. And if you pass a beam of light through this mixture, scattering of light is seen. Why? Because particles are bigger in size, light will hit these particles and it will scatter. So scattering of light is visible. So examples for suspension, we can take examples, let us say chalk powder and chalk powder in water. So this would be an example for solid in liquid suspension. For example, you can take sand and salt. Sand and salt, to mix sand and salt. This would be an example for solid and solid suspension. The third type of mixture, that is a colloid. An example for colloid would be a starch solution. Of course, we use the word solution. I will tell you why. Blood. Blood is an example for colloid, which milk is also a colloid. So these are easily relatable examples. Take for example milk. Right? When you take milk in a glass and if you observe carefully, it appears to be homogeneous, as if everything is uniformly distributed. But if you heat milk, okay, and then leave it aside, within a few minutes you see that on the top there is a layer, a creamy yellowish layer is present. What is that layer? That layer consists of fats and proteins, which means that you get two distinct layers like we got in suspension, a top layer and a bottom layer. It appears to be homogeneous, but it is not. When you boil rice in water, you get the liquid part, that is your starch solution. But if you set it aside to cool, once again you find a layer on top. These are examples for colloid. Blood appears to be again like a solution, homogeneous, but if you use a centrifuge to rotate the blood at high speed, blood can be separated into two components, a plasma liquid component and a cellular component, that is the RBC, WBC and platelets. Why does a colloid appear to be a solution? The answer lies in the property of the particles, because the size of the particles is between that of a solution and a suspension. Size is between that of a solution and suspension, that is, it is between 1 to 1000 nanometer. Not too small, not too big. Because of that, it appears to be having a uniform composition. Because the size is big, it is unstable. If you set the starch solution aside, milk aside, they form distinct layers and scattering of light is shown. This is called as Tyndall effect, named after the scientist who discovered this. Tyndall effect. So that is about our homogeneous mixtures and heterogeneous mixtures.